Okay guys, here's another example of solving logarithmic equations. If you have that flow chart out there, the first question says, does your equation have one log? The answer to this one is no. Now we have one log on each side. Okay, it says, is there exactly one log on each side? Yes, there is exactly one log on each side. There's a log on each side and they are by themselves. So if you look here, this one's taking the log of x squared minus 4 and this one's taking the log of 3x. So since we have just one log on each side, we're going to go to yes, and it says set the expressions we are taking the log of. We call those the arguments equal to each other. So we're going to take the x squared minus 4 and set it equal to 3x. Once we have that, then we are going to solve. So in order to solve, we are going to notice that we have an x squared term here. When we have an x squared term, we want to make sure we get everything to one side and 0 on the other side. We like our x squared to be positive, so don't move that. We want to move this one to this side. And so then we're going to have x squared minus 3x minus 4 equals 0. Once I get 0 to one side, I'm going to try and factor. If for some reason you could not factor, you would have to do the quadratic formula or complete the square if you prefer. So for this one, I have -4 and -3. The two numbers that make this work are -4 and +1. So that becomes x minus 4, x plus 1 is equal to 0. So my two answers would be x equals 4 and -1. Remember, you always have to check for those extraneous solutions. So if you take 4 and put it up here, 4 squared would be 16. 16 minus 4 is 12, so that's a positive number. We are fine with that. If I put a 4 here, 3 times 4 is 12, so again, that's a positive number. We are fine with that. If I put a -1 in here, -1 squared would be +1. +1 minus 4 would make a -3. We put the -1 over here would also make a -3. We cannot have an argument with a negative. So we cross that out and our answer is just x equals 4.